Hello, my name is Camila and I'll present our paper which is called Efficient Counterfactual Debiasing for Visual Question Answering. VQA is a computer vision task in which the model receives as input an image and a question regarding this image, and the goal of the model is to correctly answer the question using the visual information. We expect a model to answer truthfully based on the visual evidence contained in the image and the correct intention of the question, but this is not always the case. In this example, 80% of the bananas in the training data are yellow, so the model might use these spurious correlations and memorize the relationship between the question type and the most frequent answer associated with it during training. These are called language priors. Thus, the visual content may sometimes be completely ignored for the prediction. Exploiting these shortcuts limits the generalization of the VQA models in real-world scenarios, where the test distribution of facts, in this case the color, is different from the training distribution. A dataset called VQA-CP was proposed as a new benchmark to evaluate the progress towards mitigating these biases. This benchmark has different question-answer distributions in the training and test splits, allowing to properly identify language biases that the models may have learned. Currently, there are three main solutions to reduce language biases in VQA. The first one is to balance datasets. A well-known approach is the VQA v2 dataset, in which the authors added at least two distinct image-answer pairs for the same question. However, this is time-consuming and models can still exploit language priors. Another solution is to design specific models for mitigating biases. Most methods introduce an auxiliary question-only model to regularize the training of the VQA model. However, this approach usually requires training multiple submodels separately. The last solution that has been proposed is to change the training scheme. So far, the most efficient method in this category is CSS VQA. It is a training procedure that masks critical objects in the original image and words in the question, forcing the model to focus on the important information for answering the question, since they are penalized for guessing. The most significant drawback of this approach is the computationally inefficiency, since it requires multiple forward and backward passes. Our novel approach is a part of the changing training procedure strategy, relying on counterfactual synthesizing for addressing language biases. Here we illustrate our proposed method. ECD receives as input a set of image features, a question, and an answer. We sample Xi from an uniform distribution and test whether Xi is greater than alpha. If so, we execute model ECDV, which applies a visual mask to the critical visual features. Otherwise, we execute model ECDKey, which applies a textual mask to the critical words in the question. Then we concatenate the counterfactual instance with its original version, and we do this for the entire batch of instances. Since we lack ground truth annotations of answers for these counterfactual samples, we generate them using the negative answer assignment algorithm. The original and counterfactual samples are returned by ECD and forwarded to the training of the VQA model. We compute the loss function and ECD is called again for the next data batch. Here we show some examples of ECDV and ECDKey. The red bounding boxes for both image and question demonstrate the critical, visual, and textual information respectively, and they will be mastered in training. Here we show some examples of the negative answer assignment for VQA v2. The top 5 answers are the ones that most reliably and frequently appear throughout the dataset with these question types. Thus, they will not be considered as answers. In this table, we compare our approach in the VQA v2, CP-v2, comparing with other proposed work. We show that we achieve almost 60% of raw accuracy, beating our previous work. Here we present some qualitative results for ECD. ECD is capable of mitigating the language prior bias and correctly answer the question. Moreover, the attention match showed that the model uses critical and visual and textual information to answer the question. In this work, we present our proposed approach named Efficient Counterfactual Debiasing for VQA, which is a model-agnostic counterfactual sample synthesizing procedure. We mask critical objects from images and words from questions to create these counterfactual samples, and we also provide a new negative answer assignment that provides ground truth answers for these counterfactuals. We outperform previous state-of-the-art methods on VQA-CP-v2 while being much more computationally efficient than the previous state-of-the-art CSS. Thanks.